Hello everyone, welcome to my third day Leetcode challenge. I'll be solving the LRU cache question. And so the question is, design and implement a data structure for the least recently used LRU cache. It should support the following operations: get and put. So get key, get the value, which will always be positive, of the key if it already exists in the cache, otherwise return -1. So it's just a typical, get method for like a dictionary. And a put, set or insert the value if the key is not already present. All right. When the cache has reached its capacity, it should invalidate the least recently used item before inserting a new item. So basically, if we're putting in a key, that would be the most recently used one. If we have gotten it as well, that would also be recently used. So it's whatever key that's not either gotten put in or gotten get. The cache is initialized with a positive capacity. Got it. And there's follow-up. Could you do both operations in a one-time complexity? So we'll ignore that for now. I don't know if I can accomplish that. Here's the LRU cache. Like, you initialize it with a capacity of 2. So now it's going to only be able to hold 2 keys, right? So it's going to put key 1 with a value of 1, put key 2, value of 2. We're going to get key 1, which is going to return a value of 1. If we put key value or key 3 with a value of 3, that's going to evict key 2, right? Because we've already gotten 1. So the least recently used one would be 2. And if we look for 2, that's going to return -1 because it doesn't exist, so on and so forth. So the first thoughts I had when I saw this question was maybe we can do this with like a heap of some sort. But as I tried to implement that solution, I quickly realized a heap's not going to work, because even though you could conceive of a way to push, let's say, the least recently used key to the top of the heap whenever you put in a key, the problem is if you're going to get the key, you have to sequentially look through the whole heap again. So that just didn't work. And ultimately, I ended up using a kind of hacky solution. Imagine that, like, what we need to have if we had like a dictionary of, ignore the values for now. Let's say we just had something like that. This was our LRU cache, and we want to get 1. Okay, that's going to get put to the back of the list, right? Because that's been recently used. And 2 is now the least recently used. So if we added like a new key, like 4, should push off 2. So you can imagine, like, this kind of brings in a problem, because dictionary doesn't ever keep order in mind, right? So we'd have to use some sort of combination of like a dictionary in order to keep the get method of big old complexity of 1. And we need to keep track of this queue. We need to keep track of the order. So the way that I eventually did it was I decided to use an ordered dictionary. There's a collections library, I think it was like that. And in the collections library, there's something called an ordered dict. And that's just basically a dictionary that keeps track of the order, and you're able to move keys like to the back of the order as well. So that's going to do quite nicely for this LRU cache. Let's start with initialization. So we've been given the capacity, and that'll just be the capacity that's entered. And we want to also have this actual object that we're going to use, and I'm going to call this key value. And I think it was like this. So it's basically a dictionary. It works the same way. It's not as efficient for some reason, but you know what? That's not important for now. Just what's important is that it's a dictionary, and it's going to be able to maintain some sort of order. So let's think about when we get, right? Imagine we had this example here with 2. First we enter like 1 1. So we enter 1 1. This is going to be at it's the only one that exists. And then we put 2 2. Now this gets pushed to the back. So the least recently used then would be 1, 1. Oh, okay, so not thinking this straight. It's like this. So now least recently used is actually 1, 1, right? So if we get 1, we'll return it since our capacity is still at 2. But say that we put in 3. Now we just got to pop this guy off. Just pop this one because that hasn't been used. Now the hard part with this whole thing is if we got the key before that, let's say we just searched for the key, we got it, well then that actually gets back to the end of the list here, the end of the queue, like that. So now it's actually 2, 2. That's going to be the least recently used. Okay, so now that we kind of understand my my methodology, let's think of what we need to initialize here, or what we need to write for the get. And if we were to get, let's think. Well, we got 2 runs. Okay, so the first thing we should do is check to see if we even have it inside of our key value dictionary. Yeah, so if, well, let's just say, let's call it check, and check our key value dictionary. We'll say get, in case there's a none. We'll return default of none if the key doesn't exist, and we'll say, okay, if check exists, then what we do, we have to move it to the end of the order dictionary, right? So sorry, but I'm just gonna have to check here what it looked like. That's right, move to the end. So, okay, we want to move it to the end. We want to move it to the very back. So we enter that, and we enter the key. Now we just return our value, and I forgot that we have to use self here. So pretty sure that's pretty much it. When we get it, we check if it's there. We're going to return what we found. Oh, of course, it might not exist. So if that's the case, if check doesn't exist, then we return -1. Okay, so what about when we put it on, right? So that's when we put it, we still need to check if it's there or not. So I'm trying to think what's the best way to do this. We'll put it into the dictionary and then we'll move it, because I'm pretty sure the order dict will already put it to the end if we just set it, and if it already exists, it'll just keep the order, right? Okay, so it's something like this. We'll say we'll still keep it with checking to see if the key exists. If it does, well, then we want to move it to the end, right? Oh, and keep forgetting these things. And once we move it to the end, well, I don't think we need to do that. We'll just set it here, same way we do with the regular dictionary. We'll say put the key there and make it equal to the value. Since we've already moved it to the back, if it already existed. If it didn't, it's just gonna put it at the end anyway. And finally, if the length of this thing is beyond its capacity, we need to pop off the one in the very front. Okay, so if length of self.key value, that's the length of the list, or length of the order dictionary, it's greater than self.capacity, that's how many we can carry, then we're going to pop off the last item. Pop last, was it? No, pop item. Okay, and here with default parameter is true, we actually want to set that to false. We want to pop up the first one. So that actually caused problems for me the first time I solved this. And we'll say nope, we're going to make that false. All right, so let's try running it, see if I've messed up anything. Okay, so at least with our custom test case, we've gotten the same values, null, null, null. It's because we put, then we get 1, right? 1, we put 3. We should have pushed out 2. So then we, what is it? Get 2, that's gone, so it's -1. And then put 4, 4. That should push out 1, 1. So then when we get 1, that's gone. Then we get 3, that'll be 3. Then we get 4, it's 4. Okay. So let me see if that worked. Okay, awesome. So it did get accepted. It's I'm perfectly aware that this solution is kind of hacky. I don't know if they actually thought you'd use an ordered dictionary for that. I saw some of the answers in the discussions. They used like doubly linked lists and dictionaries. Totally reasonable. You just need to like store the head and the tail of these doubly linked lists, but it was a lot more work. And personally, like, I think as long as you explain your thinking and you're able to understand, like, people can understand why you did it this way, I think it's fine. Maybe some interviews won't accept this. Like, they want the actual, like, hard-coded base data structures. But maybe some other day I'll try to solve that way. Okay? So thank you.